Welcome to this Sahara 4 exercise. In this exercise, we will use the log calculation tool to calculate the values of new logs based on existing logs in the project. For that, let's go to our Sahara project, and first let's review which logs we can calculate based on the logs that we have available. So for that, we will go to edit logs. Let's select all of the wells, and by clicking here in curves, we can see that we have mostly all of the wells of the project have either density, the density log, or the gamma ray log, but none of them have, for example, total porosity or effective porosity, nor, for example, B shale, or as also is called, clay volume. So now the idea is that based on the different correlations, we will use the density log and the gamma ray log, or the SP log, the spontaneous potential log, to calculate these different other logs that we don't have available right now. So let's start. First, we will go to tools. Here we have the petrophysical tools. There should be here petrophysical tools. Here we have a number of different tools that we can access and calculate logs. So let's start by the most simple case, that is going to be calculate the porosity. Here, porosity, and we are going to calculate it based on the density log that, as we discussed, is available in most of the wells. So now we are going to calculate it based on parameters. We will have the rock density. The rock density is going to be defined as 2.65 grams per centimeter. Here, 2.65 grams per centimeter, cubic centimeter. And the fluid density is going to be defined in the same units as 1 gram over cubic centimeter. Here we can define which is going to be the output curve, if it's going to be total or effective porosity. In this case, we are going to activate total porosity, and the curve that we want to export it to is going to be this one, total porosity. If we want to create a new curve for the output, you can do it as well. And here we have to select in which wells we will perform the calculation. So the idea is to just select those that have available the density log. Here, as you can see, we have the typical group or word selection window, and here, by clicking this button here, we can filter by log. So now we can select just the wells that have a certain log available. As we are going to use density for the calculation of the total porosity, we will select density as the filter, and now we are going to see that from 106 we are going to go to just 93 wells with the density log available. So we will select those 93 wells by clicking OK here, and now we are going to perform the calculation just on those wells that have the density log that we will base our calculation on. We are going to check if the origin curve is okay, so it's going to be density. That's fine, the alias density is going to be selected. Here we can select different options for the depth range. Here, for example, you can define the calculation for the total range of the base curve. So in any place where we have a density value, the porosity is going to be calculated. You can define a depth range here. In this case, you can define the unit of the depth range, if it's going to be TBD or MD, measure depth or true vertical depth, or true vertical depth sub C, and the top and the base from which top to which base the calculation is going to be done for the density. From density to calculate the porosity, or if you want, you can select layers as well. In this case, the calculation is only going to be performed between the top and the base that have been defined as petrophysical data for the layers that are selected. In our case, we will do it for the total range. So now everything is right. All the configuration has been done, and we are going to click on calculate. And now we can see that we have this little report here that will show that we calculate 93 elements that in this case are the total porosity log of the different wells that we selected that have a density value. So now that we have done a basic calculation with the log calculation tool, let's check the different options that we have available. We can calculate B shale volume, porosity as we did just now, the water resistivity based on different correlations or by temperature. Here we can define the horizontal permeability as well, the water saturation, and here we have other options. For example, we have the map values. We can define a log based on the value of the grids of the map, or based on the wellbore data as well. Or we can also create a new equation that is going to create a new correlation between logs. So let's advance with the following example. Let's create now the curves of B shale. So for B shale we have two options. We have gamma ray and spontaneous potential. In general, it is better to calculate the B shale based on the gamma ray. It's more precise than spontaneous potential. So now what we will do now is select all the wells that have the gamma ray first and do the calculation for all of them, and then for all the wells that don't have the gamma ray available, we will perform the calculation then with spontaneous potential. So let's do it. First, the output curve is going to be the V shale. So this one here, this is going to be our output curve. We will use the gamma ray. So this is the correct alias. So we are not going to change anything here. Here we have to define which equation we are going to use, which in this case is going to be Clavier. Let's define here. And these two values here for the clean value and the shale value of the gamma ray are quite standard, so we are going to left it as it is in this example. We're not going to change this. So now we will perform the calculation for the total range, so we are not going to modify this either. So in any place where we have a gamma ray value, we're going to define a B shale based on Clavier. But the important thing here is to select the wells. In this case, I will clean the previous filter that we had before, and instead of selecting all the wells with density, we are going to select all the wells with a gamma ray alias, in this case any curve of gamma ray. So let's select them all, and we are going to have 31 wells with gamma ray log. So now let's click on calculate, and now similar to the previous case, we have our B shale calculated for these 31 wells. Then let's do the following case. Instead of using gamma ray, let's use a spontaneous potential. So we are going to, the output curve is going to be B shale as well. The spontaneous potential alias is going to be used here, so we will keep this option like as it is. So we will calculate for the total range as in the previous cases, and here we can select which correlation we want to use. We will use linear, and this SP clean is going to be minus 50 millivolts, and for the shale 0. So these as well are standard parameters, so we are going to left it as it is. But now the important thing is to select the wells correctly. So the idea is now to select those wells that have the we're going to filter with SP. Yes, correct. Now we have all the wells that have an SP curve, and we will add a new filter here that does those wells that don't have the gamma ray curve. So gamma ray. Here I committed a small mistake. I selected the mnemonic instead of the alias, so I will modify that. As you can see here, I selected this one, but I should select the alias, the group of SP curves. So now we have all those wells that have an SP curve, but we are discarding all those that we already calculated the B shale because they have a gamma ray value. So now we will perform this cycle calculation with these 69 wells. That, as we discussed, in general it's better to use gamma ray, but if we don't have gamma ray available, we will perform the calculation just with the spontaneous potential in those wells that don't have gamma ray available. So now let's calculate, and now we have 69 elements processed, so everything has been calculated correctly. We have calculated the B shale of all the wells that have either SP or gamma ray curves. Now let's continue. So next we are going to calculate the matrix volume with an user equation. So now let's create a new equation that is going to calculate the total matrix volume of the rock. So we are going to create a new curve as an output. Let's name it BMA. This is going to be matrix volume. The description is going to be the same, and the unit group is going to be volume ratio, because it's a relationship between a total volume and just the matrix volume. So now we have this new output curve created, and now let's create the equation that is going to define the total matrix volume calculation. For this we are going to open the equation editor here by clicking on this function button here, and now let's select our um, our curves. First we are going to go from 100%, and um, let's subtract from this 100% the B shale. We're going to use the logs, so B shale that we calculated in the previous step, and now from this let's subtract the porosity. So that is going to be logs total porosity. That is the other value that we calculated in the previous step. So now we will check if we did the equation correctly, if we write it correctly. Here we can see that the check passes the test check, and here we have the different variables that are being used in the equation. So we check that the units are correct. In this case all of them are going to be percentage, so that is correct, all of them. And now we click OK, and now we have our equation defined for the matrix volume that is going to subtract from 100% the percentage that belongs to the B shale and the percentage that belongs to the porosity. So now we will have the matrix volume defined. Now that's for the equation. Always remember to check your units here when you create a new equation. In this case it's quite simple because we have just percentage, but it might be more complicated if you have different curves or different variables. So just check that all the units that are involved in these calculations are consistent with any constant that you may have. For example, I could have used here, instead of 100, 1, and in the case that I have 1 instead of 100, I should use fraction here instead of percentage, just as an example. So if you want to load an equation, you can use this button here, or if you want to save the equation that you just defined, you can do it by clicking on this button here. And we are going to have we are going to save this equation as a different file. So that will be everything in this part. Now we are going to perform the calculation in the total range. So in any place that we have B shale and porosity, we are going to calculate this matrix volume. But what is important is the selection of wells. So now we are going to perform a similar filter as we did previously. So we are going to filter by logs, and we want to select those wells that have B shale defined here, but also total porosity. So we should have in this case, this is going to, here's something important. If you select both of them, this is going to function similar to an OR connector. So it's going to select the wells that have either total porosity or B shale. And this is not what we want. We want to do the connection with an AND connector. So we want to select those wells that have B shale, but those that also have the total porosity. So what we will do is just here, let's unselect one of them and just left total porosity here. And now we will add a new filter by clicking here again and selecting the other curve. So total porosity and B shale. And in this way, we are going to do the connection as an AND. So here what we're asking for is, please take all the wells that have total porosity and also the wells that have B shale. So the connection is going to be an AND. If you do the connection in a single filter, the connector is going to be an OR. So it's going to consider the wells that have either total porosity or B shale. So now let's select the 93 wells that are okay with this condition, and let's click OK. And now we have the 93 wells where we can perform actually this calculation. Now we will click calculate, and here you can see that we are calculating the total matrix value. And everything was okay. We have processed 93 elements. So now we have calculated the B shale, based on the gamma ray or spontaneous potential, depending on which curve we have available on each well. And we have also calculated the total porosity based on density. We have run filters to select the correct wells here for the total porosity, but also for the B shale. And finally, we created our own equation that did the relationship between the matrix volume, that is a new log that we have created now, and also the from the matrix volume to the total porosity and the B shale, that are also curves that we calculated. So here you can see how useful is this tool, because you have created a new curve based on curves that are also calculated based on other logs that you have in your project. So that will be everything for this tutorial. In the next exercise we will visualize this information in the log window. So thank you for watching, and I hope you have a great day.